Hey, this is Dr. Kruse, Elementary Statistics. We're going to calculate expected value and standard deviation and look at a couple of other things in this video. So remember mu, we've called it the population mean, and mean means average. It's what we expect to happen on average. It's kind of a guess at what we think is happening with the population. All right, so it's what we expect, expected value. There's a kind of a long way to calculate it, where you take each value times its probability of happening and add them all up. If your x is a discrete variable, like number of fish, all right, you can't have half a fish, or number of ships or number of books. You can't have half a ship or half a book. So lots of times you have to use this formula if the x's that you're dealing with are discrete. If the x's are continuous, like your weight, you can weigh 151.5 pounds, or your height, you can be 62.5 inches tall. Anything that doesn't have to be a whole number, like fish or books or ships, anything that can be measured in tinier and tinier increments, well, you can get away with using the easier formula here. This is kind of called the general form or the standard form, general form usually. So just to give you an idea of what we expect, let's say John is usually an 80% free throw shooter. All right, we just expect that because that was his stats last season or whatever. Each shot he takes has an 80% chance of going in. If he shoots 10 free throws, we expect 80% of 10 to go in. So our expected value, mu, is the number of shots we're going to let him take times the probability that a shot goes in. All right, so n times p, that's this little formula right here. We expect 8 shots to go in, 8 out of 10. 10 times 0.80 is 8. That's kind of how expected value works. Now we'll go over expected value and standard deviation more in a minute, but remember what expected value and standard deviation look like on a chart, on a normal distribution curve. If we state that outliers lie 2.5 standard deviations away from the mean, what we're saying is the average, or the population mean, or the expected value, goes in the middle here, and every step we take away from the middle is a standard deviation. So this is 1 standard deviation above the expected value. This is 2 standard deviations above the expected value, and this is 3 standard deviations above the expected value. And it works the same thing for below average. 1 standard deviation below average or below the expected value, 2 steps below, 3 steps below. All right, your normal distribution curve. Now your 0, 1, 2, 3 numbers are called z numbers. All right, we'll calculate z-scores in another lesson. Your x numbers are whatever numbers go with your word problem or your story. So this story here says we expect a value of 80, give or take 5, with a standard deviation of 5. So our expected value, our mean, goes in the middle, 80, and then every step is worth 5. So I have to add 5 to get 85, plus 5 is 90, plus 5 is 95. And I do the same thing going the other way, minus 5, minus 5, minus 5. Now the question is, name some possible outliers, and they've defined an outlier as 2.5 steps away from the middle, 2.5 steps away from the expected value. So just kind of eyeball where that is. Here's 1 step above, 2 steps above, 2.5 would be right there. So if we drop down to our story problem numbers, it's in between 90 and 95. So that'd be about 92.5. So if I was going to name some possible outliers, I'd say 93 is further away, 94, 95, 96, 97, 98, 99. Any of those values is more than 2.5 steps above the expected value. Going the other way, 1 step, 2 steps, 2.5 standard deviations below the expected value. It's right there. Drop down to your word problem numbers. It's going to be between 65 and 70. That's 67, 67.5. All right, so anything lower than 67.5, like 67, 66, 65, 64, 63, etc., all of those numbers would be outliers as well. They'd be unusually low, just like these were unusually high. All right, let's look at a couple of ways they could ask you questions about expected value and standard deviation. This one says a company finds long-lost friends. They have a 70% success rate. So if you just submit one name of one friend, what's the odds they find that friend? There's about a 70% probability that they would find a single friend. That's our p-value. All right, the probability of a single success is 70%, which means Q, the probability of not success, is 30%, or the probability of failure, if you want to think it that way. So they have a 70% success rate. You're going to submit 5 names. So you're going to give them 5 names, and let's answer a bunch of questions about that. So N is going to be 5. If they ask you to make a histogram, remember that's just a bar chart, usually bars running up and down. Well, first look up your probabilities and just kind of think of them as ordered pairs. So I have a group of 5 with a probability of a single success of 70%. All right, so I get my good old binomial probability distribution table here. And just by the way, all of these numbers were calculated using this formula. We were doing a probability of a single success, P, all right? That's if you play a single hand of blackjack or play a game a single time or submit one name of those friends of yours. They said the probability in this instance of finding that single friend was 70%. So I'm in the 70% column, and I want to come down to a group of 5. I'm going to submit 5 names. So 2, 3, 4, 5. I'm in this cluster right here. So 70%, and I'm in here in the group of 5. So these percentages right here are the probability of finding 0 out of 5 friends, 1 out of 5, 2 out of 5, 3 out of 5, 4 out of 5, and all 5 friends. That's the probabilities over here in the 70% chance column. So there's a 0.002 chance that I submit 5 names and they find none of the 5. There's a 0.028 chance or probability that they find 1 out of the 5 names that I submitted, and so on. All right. So if I write those down, the probability that R equals 0 is 0.002. We just saw that. Probability of them finding 1 out of 5 is about 3%, 0.03 roughly. Probability of 2 out of 5, about 13% chance they'll find 2 of my 5 friends. There's about a 31% chance they'll find 3 of my 5 friends. There's about a 36% chance they'll find 4 of my 5 friends. And there's about a 17% chance they'll find all 5 friends. Just to check, these should add up to 1. All right, they should add up to 100% if you're speaking percents, and they should add up to 1 if you're speaking decimal. They add up to 0.999. That's a rounding error because this is rounded, 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 rounded. We rounded 6 numbers. So that's like introducing 6 tiny, tiny mistakes into your sum. So all of those mistakes added up together made our sum off just a smidge, but that's close enough. 0.999, we're going to call that 1. So look at this and think of these as ordered pairs when you're trying to figure out, which histogram is which. This is X, this is Y. Think of it that way. So when you're looking at the histogram or the bar chart, this bar that's labeled 0 should be this tall. Should be like 2 steps tall if I ignore the decimal. This bar that's labeled 1 should be 28 steps tall, and this bar should be 132 steps tall. This one should be 309 steps tall, this should be 360 steps tall, and this one should be 168 steps tall. So sometimes it helps if you kind of ignore the decimal and you can kind of see how tall each bar should be. The bar over the 4 should be the tallest, and the bar over the 3 should be the second tallest. That helps a lot. All right, let's calculate the expected value, mu. What do we expect to happen? Well, I'm going to submit 5 names, n is 5, and the probability that they find a single name, if I just submit one name, the probability of them finding a single name is 70%. So n times p is 5 times 0.70. We expect them to find 3.5 friends because they said they find 70% of the names you submit. So 70% of 5 names is 3.5. Now, of course, there's no such thing as 0.5 friends, so we expect them to find 3 or 4, all right? as low as 3, as many as 4. Now here's our give or take calculation, our standard deviation. Just the square root of n times p times q. So 5 names times 70% probability of a single success times the probability of failure. Don't forget the square root. So our give or take number, our standard deviation, is 1.02. So we expect them to find 3.5 friends, give or take 1.02. So they'll find 3.5 friends, give or take a friend. So it could be as low as 2.5 friends, or it could be as high as 4.5 friends. We really don't expect them to find all 5 friends. Okay, another thing they might ask you is, how many names would you have to submit to be this certain, could be 96%, 95%, 98%, to be this certain or this sure that they'll find at least 2. So I'm asking for the probability of at least 2, which means the probability that x is greater than or equal to 2. That should probably be an R, but that's okay. So the probability of at least 2, that means it can be equal to 2 and it can be greater than 2. So they're talking about the probability of 2 plus the probability of 3 plus however many I need to get the probabilities to add up to 96% or better. So just for a starting place, let's start with a group of 3. So if I'm in a group of 3 and I want the probability of at least 2, that would be the probability of 2 plus the probability of 3. So back to our table, 70% column, I'm in a group of 3. All right, so I'm submitting 3 names. I'm looking at these probabilities here. This is the probability they find 0. This is the probability 1 out of 3, 2 out of 3, and all 3 friends, 3 out of 3. The question was, what's the probability of at least 2? Well, this is 2, and this is 3. So at least 2 would be 2 plus 3. I'm going to add those 2 probabilities. And those 2 probabilities add up to 0.784. So I'm about 78% sure. If I submit 3 names, I'm about 78% sure they'll find at least 2. All right, that's not what they asked. They asked how many names, what would n need to be for us to be 96% sure. So let's make our group bigger and try again. So let's move to a group of 4. Probability R is greater than or equal to 2 is 2 plus 3 plus 4. Just at least 2. Could be 2, could be more than 2. And we have to stop here because we're at a group of 4. I looked those up in the probability table. All right, so I'm in a 70% probability of a single success. I'm in a group of 4. I'm looking at this cluster right here, these rows. So right here, this is the probability of 0, probability of 1, probability of 2, 3, and 4. That's the ones I want. I want 2, 3, and 4. Probability of at least 2. So it could be 2, could be 3, could be 4. I need to add those 3 up. Okay, so I add those 3 up, adds up to, let's call that 92%. Getting closer, but I'm not 96% yet. So let's make our group a little bit bigger. I go to a group of 5. I'm going to submit 5 names. What's the probability of at least 2? That's the probability of 2 plus 3 plus 4 plus 5. I go to the table, I look up those probabilities, adds up to 96.9%. So roughly 97% sure of finding at least 2 friends. And that satisfies our question. They asked, how big a group would you need? How many names would you have to submit to be 96% sure? Well, 4 wasn't enough because we were only 92% sure, but 5 was enough. If we submit 5 names, we're 97% sure that they'll find at least 2. Could find 2, could find 3, could find 4, could find 5, but they'll find at least 2. So n needs to be 5. So if you submit 5 names, you can be 96.9% sure that the company will find at least 2 friends. All right, here's another look at a problem. 25% of paroled prisoners become repeat offenders. That means they end up going back to jail. So let's say you have a group of 4. You have 4 names. And let's define success as a person will not become a repeat offender. So we got to think about that. If 25% become repeat offenders, well, then I have to look for a question that says will become a repeat offender. If it says will become, then I need to be looking in the 25% column. If it says will not become, a repeat offender, then I'm in the 75% column. All right, so P and Q change places. P is whatever your question is asking. So if your question is asking about will not, which is what we define success to start with, we defined it as will not. If success is will not, well, you got to figure out what percent that is. 75% will not. All right. So if your question asks how many will not become a repeat offender, you're going to use a p-value of 75%. If your question asks how many will become a repeat offender, you're going to have to change columns and use a p-value of 25%. All right, here's our probabilities from the table. We're accepting that a person will not become a repeat offender. We're looking at those probabilities. So we're looking in the 75% column. There's a 75% chance that if I grab one of these 4 people randomly, there's a 75% chance they will not go back to jail. Here's our probabilities. Again, if you're making a histogram, just think of these as ordered pairs. What's the expected number of parolees who will not repeat? Be careful and read that carefully. Will not, that means probability of a single success is 75%. Even though they gave us information about the 25%, if we're measuring will not, we need to use the 75% column. All right, the expected number is the number of names or number of people times the probability that a single person will not go back to jail. So I'm going to submit 4 names, and the probability that a single person will not go back to jail is 0.75. So we expect that 3 out of 4 will not be repeat offenders. That kind of makes sense. 75% is 3 out of 4. We expect that 3 out of 4 will not go back to jail. All right, here's another how large a group question. So how large a group do we need to be 98% sure that 3 or more will not become repeat offenders? So will not tells us what column we're working with. We're in the 75% column. 3 or more, that means 3, 4, 5, 6, 7, 8, anything bigger than 3. 3 or more. X can be 3, but X can also be bigger than 3. So 3, 4, whatever else. I just started randomly at a group of 5. With a group of 5, the probability that R is greater than or equal to 3 is the probability of 3 plus 4 plus 5. I pull these values from the table. In a group of 5, with a group of 5, I can only be about 90% certain that 3 will not, I can only be 90% certain that 3 or more will not become repeat offenders. So that's not certain enough. That's not a high enough percent. So I need to make my group a little bigger. So let's bump it up to 6. If I bump it up to 6, the probability that R is bigger than or equal to 3 is the probability of 3 plus 4 plus 5 plus 6. Grab these out of your table, add them up. Now I'm 96% sure. I'm getting there, but I'm not quite to 98%. We probably need to add 1 more, and that's what you need to do. Just bump your group up to 7, find the probability of 3 plus 4 plus 5 plus 6 plus 7, and that'll give you a high enough percent so that you can be 98% sure or better that 3 or more will not become repeat offenders.